Have you ever noticed how certain patterns seem to repeat everywhere, from the swirl of a seashell to the branching of a tree? It is truly amazing how often numbers can describe these natural wonders. People find famous math sequences by observing the world around them, making careful measurements, and then applying logical and mathematical reasoning to uncover the underlying rules. It is a fascinating blend of curiosity, observation, and rigorous analysis. The core mechanism often begins with a keen eye for repetition or progression in seemingly unrelated events or structures. Mathematicians and naturalists might collect data, measuring petal counts on flowers, the spirals in pine cones, or the breeding patterns of animals. They then look for relationships between consecutive numbers in a series. This could involve examining the difference between terms, the ratio from one term to the next, or even the sum of previous terms. For example, the well-known Fibonacci sequence, where each number is the sum of the two preceding ones like 1, 1, 2, 3, 5, 8, and so on, was first described by observing rabbit populations and later found in countless biological formations. This process of identifying a rule that governs the numbers allows for prediction and a deeper understanding of the phenomenon. So, how can you start to spot these patterns yourself? Begin by listing numbers from a natural observation or a simple problem. Next, calculate the differences between consecutive terms, then the differences of those differences. Sometimes a constant difference or a constant ratio will emerge. Consider the possibility that each term might be related to the one before it, or even to the sum of all preceding terms. These basic investigative steps are the starting point for uncovering numerical truths. Beyond simple addition or multiplication, discoverers often employ tools like recursive definitions, which state that a term is defined by preceding terms, or generating functions, which are algebraic expressions that encode an infinite sequence of numbers. These advanced concepts help formalize the patterns observed and prove their universal nature. Many sequences, like the Fibonacci numbers, are part of a larger concept called the golden ratio, a special number approximately 1.618, which appears repeatedly in art, architecture, and biology, showcasing an incredible mathematical harmony. Understanding how people discover these famous math sequences is not just about memorizing numbers. It is about appreciating the power of observation, the elegance of mathematical thinking, and how these tools allow us to decode the hidden patterns that connect our world, from the smallest seed to the largest galaxy. It truly empowers us to see the world through a clearer and more insightful lens.
If you love exploring numbers, like, subscribe, and keep counting with us.